Okay, pressing record. Anybody have a preference on starting?
No.
So where am I at the moment? That last we spoke, I had begun the process of tuning my PID. I'm trying to find my share button. Why has it disappeared? There it is. And Jeff pointed out, thank you, Jeff, for giving it some mental brain power. Hey, I've got this GPS, why don't I use it? And so I dug back into my GPS to try to use it as a benchmark on speed. And bottom line is I've been trying to get my GPS up and running. And I just want to give you a sort of a summary of where I'm at the moment on my GPS. So at the moment, I have got my GPS trying to find the actual commands so you can see the commands that I'm feeding it. So I'm running that command. And I mean, you guys can point out errors of my way. I'm just telling you where I'm at. That command is working. And I have these NEMA, I think they're NEMA, I've forgotten the actual statements, the acronym, I'm trying to get to them. It's not those, it's not those. Oh, come on. These are the three, I'll make that bigger.
So the RMC has speed over ground.
And again, I'm a hack, so I don't know if I'm using the right ones or not, but these are the three that I have started with. So the GPGGA, GPRMC, GPGSA at 5 times a second. So that's working and has been running, overnight and spitting out, output on my Ubuntu laptop. I haven't got it running on my Raspberry Pi yet, but that's where I'm at the moment. So now I need to move that process to my Raspberry Pi and go through the process of using that input into comparing it to the speed that my onboard speed measurement device is telling me. So some progress, painfully slow, but some progress. But this, the echo command that I'm using is only the fix. So I haven't, which gives me the lat long. Does anybody know more about what other topics are out there on this by chance?
If you do a topic list, what is it showing you?
Yeah, I'm not in front of that machine. I haven't done that yet. It was 10 o'clock last night when I got that to work, so but I'll do that.
Because that driver is going to give you certain topics out, and then whatever, as long as you're putting the correct NEMA sentences into it, it'll give you certain topics out. So see what your list of topics is, and then see if one of those, if it's actually publishing a speed at that point. And that's the same one, Matt, that's the same one you're running, and that's basically what's there.
Yep. That's the one that I use.
That was the same Ross run statement effectively?
Yeah, just a kind of a generic driver that will read off of your serial port. And if you
Cool.
want to see how, like, what is available, what nodes are available out here on the wiki, you can, this is for the NEMA Navsat driver, and then it will kind of tell you how to start it up, but has subscribed topics and then published topics. And so your three published topics from this driver are fixed, velocity, and time reference. And so you could use this message here, this velocity message, to compare velocity of your wheel encoders if you'd like.
Does that velocity publish X and Y velocity, or does it publish forward velocity?
X and Y. So you'll need
So-
to convert that.
Is there a quick way to get to save your NEMA sentences? Because that'll have it directly. It'll have the your velocity, your forward velocity directly coming out of that.
Yeah, the RMC message, the GG, that one has speed over ground directly in that message. And so Al has that message coming across.
So does that Navsat driver give you the option to publish the raw messages?
Yes, yeah, you can say RMC true, use RMC true. I can show you that.
But does it publish that out as a topic? Does it take all the sentences coming in and republish that as, say, a NEMA topic? That would be handy, because then you could see the original stuff.
Okay, yep, this driver has a couple of different functions. And so, and there's another one that'll just read in and then publish your, this topics serial reader. One will take in and then just publish this NEMA sentence, the raw NEMA sentence, and then you can use this serial reader to read in the NEMA sentence and then print out the data. If you want the raw, you're asking for the raw message.
Yeah, it just seems to be quicker. You can just look at it and it says you are moving 2 meters per second, and then you know you're moving 2 meters per second. So you don't have to take the X and the Y and convert that into a vector to get your forward velocity.
Right. Okay. So the default one has this use RMC off, but you can turn it on and then that will output. And you can take a look at how that's going to give you speed over ground and heading, I think.
And so have you ever tried to use any of this, Matt, to validate your speed data?
Yeah, it's a great, it's the best sensor. Your GPS is the great ground truth.
So
So setting that,
can you quickly say what the steps were you've used to do that, so Al knows what he's looking for?
Okay.
Jeff not only is technically smart, he reads minds.
Yeah. So
I'm just translating at this point.
So you'll have to pass in an argument. If you use ROS run instead of a launch file, you'll want to pass in this argument, use RMC equals true. Is that what you mean?
Well, just the fact that what he wants to do, he always takes his vehicle out in the yard, point it in some direction and say, go. And if he's recording something to his bag files, he can go back later, and his existing software will say, this is how fast it thought it was going, and then look at the message coming from the GPS, and it says, this is how fast it thought it was going. And those two should be the same value. So I just wondered, what does he need to look at, and is there any other special setup? But if you just change that RMC to true, that might do the job. Does it publish a different message in when you do that, or just simply the velocity message changes to course over ground and speed over ground?
It's a good question.
As opposed to X and Y velocity.
I think I just took the X and Y velocity and built it out of that, compared the speed to that.
So if we back up what Matt was saying about there's different nodes inside of that one package, what you can do is you can split it apart. So you run the one that says, I think it's the NEMA serial reader, and that takes messages from your GPS and publishes those out as a NEMA topic or NEMA sentence or something. And you start up another node, it's the other half of that, and it says read in from those serial messages, or read in those NEMA messages, and then publish out the fix and the other stuff. So basically you're running two nodes. And when you do that, that means you've got an extra topic being published that's called sentences or NEMA or something. And then those can show up directly in your bag file. So then when you play it back, you'll have both the raw data coming in and you'll have the fix and the velocity and whatever that other one was.
And that second node that I'm using that's going to take that X and Y, is that code that I'm writing, Matt, or is that code that you've already written to take that X and Y and translate that into a speed?
Well, let me clarify a little more. I'm saying if you do what I just said, you don't have to do Matt's translation. It'll just be, the data will be there. So if you go back, if you pull up that web page again, that was the wiki, and it said, here's the NavSat driver. And then in there are like three different things you can run. You can either run the one you have that does both things. It reads in the serial data and publishes the topic, or you can start up the one that just reads the serial data and publishes that as NEMA sentences, which is human readable, and it's the speed over ground that you want. And then you start the second node, and it takes in those NEMA sentences and publishes the fix and the velocity. So if you just break that apart into two nodes running, then you'll just automatically get the raw messages, so you can save them and go look at them. Now beyond that, you could go do the thing that Matt's doing, where he's got the code to take his X and Y velocity and convert that into forward speed or whatever he's doing. But I'm just saying, if you do this other method with the split that into two nodes, that you probably get what you want, and then you can always go back later and say, what was it doing at this time? And you go pull up the timestamp and look at your bag file, and it'll say, this is how fast I was going, and this is the heading, the direction I was going. So you've got one node there, right there. It says NEMA serial driver, and another one's called NEMA serial reader or something like that. So I think you have to run those two instead of the one you're running now. And you still might have to turn on that use RMC. I'm not sure. That just says take one of the NEMA sentences as opposed to the other to generate your velocities off from, I think is what that's doing.
You're saying run one or the other. I'm seeing this has these topics.
So if you go clear to the top, is that the node you're running? So you're running NEMA topic driver. Is that the one you're running right now?
He's running serial driver.
I don't remember. I have to go back to the statement.
It's been a long time since I've done this, so I'm not sure exactly what it is, but I know there's one that's a combination of everything, and that's the one you're apparently running right now. And then they say, or if you want to do something different, it says you can read this one that just reads the serial data and publishes it. And then in order to make that into what you want, then you run the third node that they provide that takes those NEMA sentences and puts out the right stuff.
I don't know if you can see that. It's the NEMA underscore serial driver.
Yeah, I can see that.
I can't get to my. I can't tagnet it. So this isn't the one that I'm actually running.
Well,
So there's 3 nodes inside of there, which maybe is confusing you. There's a serial driver, a topic driver.
Yes. Doesn't take much to confuse me.
So that bottom one, it's up a couple lines. It will say topic driver or something. I don't know if you can move up a couple lines on your screen. I guess the other direction. There we
Right
go.
there, right there.
4.3. That's what Jeff's saying. It says first, take in your raw NEMA data and just publish that raw NEMA data out on a topic. So you'll have all your NEMA sentences published out on a raw topic.
All right.
And then you can start another node that reads in that topic and then converts it to lat long and publishes over fix. You're using the serial driver, which does both. You're reading off the NEMA stream from your serial and then publishing to fix.
And what is going to
Either 4.1 or 4.2 is the next thing you want to run. So
4.1.
probably 4.1. See, it takes in NEMA sentences and it publishes out your fix and velocity. So all that's doing is splitting those two things apart. So you've got the NEMA sentences in between. And in
so
your
instead
case,
of this, it's going to be that?
No.
well, you're going to have two. You're going to have to start two things. So you want to start this as the second thing you start, but if you scroll down to 4.3, that's the first thing you want to start.
Okay.
So you want to put that one in, and as Matt says, you might have to put that parameter of set RMC to true. And then that will, if you run that, then it should start publishing. If you look at your topics, it should start publishing these NEMA sentences and you can see them. And then the next line in wherever your startup code was, you're going to have to start a second node. And that'll be the one, whatever 4.1 says.
So Alan, you got all that right?
No, I am puzzled, but I can talk here in my update about what I'm trying to do with this.
No, because, you know, like I'm going to do that tomorrow and then you got to do it next week. I'm just messing with you.
Slowly building up some capabilities, but slow is the operative word.
Thank you, gentlemen. I'm sure there's about 6 questions between here and me successfully doing that. So that's what's going on in my world.
So I had a question for you guys as you were talking through that. So to, kind of Jeff's example is good, right? You've got the lawn tractor out in the yard and you tell it to go somewhere and it should in theory go there, avoiding obstacles and all those good things. Do you, in your, I don't want to talk about this, in your presentation of your data, so you probably put into something like Arviz or Gazebo or something like that, ultimately, do you present, your lat longs come in as whatever those numbers are, they're really big numbers with lots of decimal places. Are you going to localize that into, say, feet from a starting point on an XY coordinate in your yard? And are you going to make a local coordinate system, or are you going to keep using the lat longs, or what are your thoughts in terms of where's your coordinate system 0, 0 going to be? How have you typically thought about that?
I believe Matt is already doing that, so maybe he can tell you where his code is that does that. So people have this all figured out. Was that under the ClearPath website where they talk about localization? They tell you how to do all this, where you take in your GPS, you feed it into something called a UTM converter, which converts it down to meters. And then somewhere you feed in an offset saying, here's my point in my yard that's going to be 0, 0. And by the time it's done, it's putting out like an XY position in meters. So you don't have to deal with latitude and longitude. And then somewhere after that, they add some more stuff on to feed it into that robot localization node that's running out some kind of a Kalman filter. So that's documented somewhere step by step how to do that. And I assume that's what Matt's got in his stuff for either the simulator or what he's running on the actual lawn tractor right now. So maybe he can point out what those are.
Yep, Alan, it's just exactly like that EDX class. So you remember that the map had an origin, a 00 in the factory?
And they kind of put it right in the middle, if I remember right.
Exactly. Map origin is in the middle. And then it's meters. It's called, you can call it local coordinates or Cartesian coordinates, but everything derives its position from that origin. So for a GPS context, if GPS is just localization, just tells you where you are. So you can do that a number of different ways, but in the GPS context, you'll also have an origin, and then you'll convert to meters from that spot. And you can use a number of packages to do that. There's a NavSat transform that is used before it goes into robot localization to convert your global coordinates into local Cartesian coordinates, or like what I use at the AgBot challenge is just called GPS pose. And it also does the same thing. You basically have a function, but you just send in whatever your 00 is, and then your GPS will be measured off of that point. But generally, it's just all in local coordinates.
So do you, in those challenges, for example, do you, when you get to the site and you get set up, do you then go to a spot in the field or yard and say, this is where my 00 is going to be? Or do you make it where you have like a tent set up with a workstation and that's your home position? You kind of measure off of that? Or do you go out into the field and say, let's say I got a rectangular field. Do I pick one corner of the field to make my 00? Or do you go out into the middle of the field and make that your 0 point? Or to me, it seems like you'd want to have everything be in the upper right-hand quadrant so that everything is in a positive number. But I won't do it the right way, the way people think should be done too. So.
Yep, I'm a little bit of a neophyte here, and I've used different autonomy systems. So each system's a little bit different, but generally what I do in reference to the GPS localization is I call my base station 00. And generally I put my GPS base station into an area that's not going to change. So I always have that point of reference.
Okay.
I mean, I have mapped entire fields and then had to move where my base station is. The next year.
I'm thinking of it too in terms of if I've got a field, a couple acres, and I've got subparcels in there with different types of crops in each subparcel. Should I be restarting every subfield, or should I have a coordinate system that covers my entire property? And then, my starting point would be, always relative to the same base point. Those kinds of questions.
So a more generic answer is it really makes no difference where you put your origin. You just put it somewhere that you can recognize. And as you say, you'd like to get positive coordinates off that. So you can, and then as Matt says, you can move that around anytime you want. But to your question you just asked, do you want to do your entire property? A lot of that's going to depend on trying to get your base station for your GPS. Can you transmit far enough to do that? You may physically have to pick up your base station and move it, depending on the size of your property and the kinds of radio transmitters you're using. Now, if you're using the DOT data and you're using a cell modem, then you don't have that problem anymore. Just simply, you turn that on and it says, oh, you're right here on the face of the earth, and you don't care. So then you have to go in, somewhere you have to go into the code and say, this is my origin point. And I think it's like a parameter you put in and say, my origin is this latitude and this longitude. So you can make up whatever you want. So you go to your field, and you go to the corner and you measure that latitude and longitude, enter that in as a parameter, and then that becomes 00 to the stuff that Ross is doing. So if you want to have subfields, you could say then go to the next place where you have it. So for each one, you just have to put in a parameter saying where your 00 point is, I think. I haven't actually done this in a big field, so I'm not sure, but I think that should work. And then as Matt said, if he had to move his base station, well then if it's down to just an offset in meters, that if you move your base station, you just have to figure what's my X and Y offset from where it was to where it is now and just subtract that off that parameter saying where your base station is located, I think is all that would require.
Yeah, your GPS base station is good to 10 kilometers. So if you have you should be able to map out your whole field.
But that depends if you have enough radio power to communicate to your rover. That's the biggest problem right there.
Yeah, I think on the Arju Simple websites, I kind of went through that, and I actually set up some time with them sometime next week for an hour to talk through different alternatives, and then based on that decide which system to get. But it seems like they have a real short-term radio, a medium-term radio, and then a long-term radio. And I don't want to say the numbers with any certainty, but it seems like the long range was, like Matt suggested, 10 plus kilometers. And then the medium range, which seemed to be big enough for me, was something like 3,200. You have a long range. There you go. Yep. So you should be good for 10 kilometers or whatever, right? Then there's a kind of a medium range, which was like 3,000 to 4,000 meters, if I'm not mistaken. You gotta go look at the website and see. But and then the short range was something less than that. So
But the other thing you have to consider, they're going to tell you this is the range on it, but in reality, that's probably not what you're going to get. So it might be better.
so I should for bigger than I really need.
That's just a fact. That's what people are going to tell you. They say, oh, this radio can get
Yeah.
you up to 500 miles, but in reality, it won't
Yeah.
do that. So
That's a good point.
your best bet might be go to Google and punch in whatever the type of radio, if they're running the XB, and say XB long range, says what is the real range, or you'll find people testing this stuff out, and they'll tell you what they're really getting on it. And it also depends whether or not, if you've got a flat open field with no trees around the edge.
Yeah.
Again, it depends where your base station is. If your base
Yeah. Good
station
point.
is line of sight to your entire field, you got a much better chance of it working than if your base station is at your house and you got to go, quite a long distance, and then you got rows of trees in between. That's going
Right.
to affect it too. So
Okay. Yeah. Yeah. Okay. You convinced me I need to go with the long range then. I thought I'd save a few bucks and go with but yeah, no, that's a good point. So in terms of the base station, I'm wondering, this is a question I have to ask yet, but I'll just throw it out there as an open question. We talked then in Slack about the SBC, the Arju Simple that had the SBC, single board computer. I'm wondering if I could make that as my base station, and then let's say put that at my house, put it in my house, and then just get one of those better antennas and put it on my roof of my house. And that would be my permanent base station. And then the SBC could be the entire, that could be all of it, right? I wouldn't have to have it hooked up to my computer. It could just be always on, always running. And then I don't have to worry about dragging the antenna and the GPS base station around every time I go out to set up to do something outside. It would just always be there ready to go. So I don't know if anybody knows on that. Otherwise, that's one of the questions I'm going to ask them, just to clarify if I could do something like that.
So one of the first things you should ask them is, does that SBC really exist? And I think it's just, I don't think it does. I think it's vaporware. They're saying, if you want, we will custom design this SBC computer for you, and we're going to charge you a lot of money to do that. So that's the first thing you'll want to ask them.
Yeah.
On
Okay.
the webpage, they don't tell you how much it costs, but then down below they're showing you, well, here's all your options, and they show you a little 3D printout of what they could do. So I think it's just a matter, I think it's just advertising their design services, what that SBC is. But as far as setting up a base station, if you just take one of these that's the size of the Arduino and connect that, you can buy that one and buy their little plug-in radio module and put power on that, and that will create a base station wherever you want to put that. So if you buy the radio module that takes an external antenna, you could put a better antenna. And again, I don't know, that radio that Matt was holding up, is that actually for the Arju Simple, or is that just another radio he had laid around as a long range?
It's just a serial radio.
So that's not one that they're selling. I knew they sold at least two different types of radios with their Arju Simple, and I didn't know if they had another one that was beyond what that was. But one of them has an external antenna connector, so I assume you could put an antenna up on your roof or whatever, and you might want to put the whole thing up on the roof. Just be careful of lightning. That's your next problem there. But you don't need anything really fancy to do this, because the just one of those single boards which has the module on talking to a radio will give you what you need as a base station. So you don't need to get the SBC, whatever that thing actually is. And the other thing I was wondering about that little, the small module, or the one they call their heading module, that's a smaller board that actually plugs into the radio socket. So they did something clever where they originally designed it. They had the board the size of a Arduino and a little plug-in where you plug in the XB board. So they figured out if you unplug that radio, they made a module that goes in between there, and they have pins sticking out the bottom and pins sticking out the top. So it acts like, to the main board, it acts, the chip on the board, the F9P on the board, acts like the radio. It thinks it's talking to the radio. So basically you have a UART on the add-on F9P talking to the main F9P on the board down below, and then the pins sticking up. Then they've moved it around and run a different UART up, so you can still plug one of their radios on top of that. And if you're going to be talking to them, you can just quiz them, who's using this and how well is it working, and just in general, what radios do they run, what kind of range can you get out of it, and number one, is everybody happy with it? It seems like,
Okay.
the little board plugged into the big board is basically the same thing. I just simply have two big boards bolted down to a plate with a piece of wire between the two. And what they're doing, again, it kind of limits you a little more in what you can do, because again, they're trying to wedge that in what they already had. So I don't know if you could buy just a little board and make it do everything you want, or if you have to buy the bigger board to make it more flexible. So that's some more questions that could come up. It almost looks like you could buy the little board and plug a USB cable in and do everything that I'm doing right now if you don't want to run the moving baseline. But anyway, another problem I'm running into is that I wrote up configuration files just to hook my two random boards together. And then when they made their one with the little board on top of the big board, they made up their own configuration files, and they used different UARTs and passed in the correction data on different ports and everything. So I had one guy that tried to load their configuration files and run my driver, which is not going to work, because it's you got to go through and tell it which UARTs to use and all this kind of stuff. So just in general, it's very flexible, but that causes problems when you got people trying to piece this stuff together and taking bits and pieces from here and there and trying to make it work. But as far as building a base station, if you go to their website and they talk about, here's the setup tutorial or something, they will say, here's how you set up a base station at a fixed location, and here's how you set up the rover. And they show you, if you buy these boards, you plug in these radios and use this configuration, that should indeed work. And then they added the confusion a little bit, because then they made the little tiny board that plugs in for the heading. And in reality, that's just another receiver. It's the same kind of receiver. It's just that the configuration lets you plug it in and connect it without having extra wires like I'm doing.
Yeah, cool. Yeah, I just don't want to, if I can help it, I don't want to tie up an extra computer just to run my base station.
Yeah, if you're just talking directly to a radio, you shouldn't need another computer at all. The chip itself generates these codes and sends them out in a binary format over one of the UARTs. And if you plug in their little XB radio right into that board, it just transmits those. And then at the other end, if you say on your vehicle, if you want to have their big board and a little board plugged together so you can get the heading, then again, that I don't believe, you don't need a computer there unless you're trying to feed. No, that should work. So if you buy their big Arduino board and their little plug-in heading board, and then buy one of the radios, that's everything you need to put on your vehicle, and you don't need any extra computers to do that. And then if you're a base station, you need something that's the receiver and then a radio at that end, and you don't need a computer there either.
Cool. That was good. Is there the other option? It seems to be saying that I could put both base station and the second GPS device onto my vehicle. So I'd have basically the rover GPS and the base station GPS. Both pieces could be on my vehicle. Am I understanding that right, or am I reading that wrong? And then I could do away with a fixed base station entirely.
If
Is
you
that
have,
how it works?
if you have two receivers on your vehicle, the first receiver is receiving satellite data and creating correction data for the second one. And the second one takes that in and does what they call a moving baseline. And it's, so the result of that, if you look at that nav rail pause message, whatever it's called, it tells you the distance between the two antennas and the heading between the two antennas. So you can get a static heading very precisely with no extra correction data, but you don't have the first receiver, which is going to give you your XY position. If you don't feed correction data into that from a fixed base station somewhere, then it's not going to give you an RTK fix. So it's going to kind
Okay.
of wander around like everything else does.
Gotcha.
So in reality, you would
gonna-
have to have 3 complete receivers if you want to do your own base
Okay.
station and do moving baseline on your vehicle. It'll take a total of 3 receivers to do that. Or
Yeah.
again, if you use the DOT data, you don't need your own base station. You can feed it cell modem data,
Yeah.
pipe it into it somehow.
Okay. And is heading pretty important?
Critical.
Critical. And I guess, okay, so it's super critical. I want to play devil's advocate on that a little bit, but I don't know if I should or not.
Go for it.
Just, it's helping me understand it a little bit better. So if I know where I'm at, for example, especially now when I've got a 4-wheeled vehicle with Ackerman steering, okay, I get it maybe if I had a 2-wheeled vehicle that could pivot, any way it wanted to, but since I've got a 4-wheel vehicle with Ackerman steering, it's not going to flip around on me and be heading some other direction. It's going to always be going in a certain direction. And if it's GPS, let's say I'm trying to follow a line, for example, it starts getting off of that line. I guess there probably are multiple ways it could get off of that line. It could slide to the side on a little side hill, or it could be pivoting somewhere or another. I really wouldn't know which way it's slipping off of the line, would I? I was just thinking it'd just be real easy to correct it back onto the line by whichever way I'm going, just steer back the other way. But I can see where, I guess maybe that's why you need heading, is to know, well, how did it slip off the line? Is that kind of the thought there?
You need closed loop control.
I need closed loop control.
Yeah, so you need to have some measurement or sensor on heading so you can get back to the desired heading that you're shooting for.
So I don't have to worry about it. So it automatically happens.
No, it doesn't automatically happen. It's
What?
called cross-track error. And
Cross track error. Okay.
getting back on track is we talked about it last week. We have 3 approaches on getting back on track.
Oh, okay. I'll go watch last week.
And Matt has all of the secret sauce and can explain it in great detail.
So it's not automatic and easy. I thought it was automatic and easy.
Yep.
Just like everything else, right?
Yep. Heading's one of the easiest things in robots. Knowing where you are is one of the easiest problems in robots, but mainly where you're pointing. Which direction are you pointing?
Okay.
To back up a few thoughts, you said you're
Yeah.
driving along and knowing what your heading is. Well, as long as you're moving on your GPS will give you a heading as long as you're moving. But if you come to a stop, it stops reporting a heading. In fact, depending which message coming out you're looking at, when it comes to a stop and you're, the little, the points are bouncing around like this. Well, each time it bounces around, your heading swings around like this for every calculation that it does when you're at a stop. So if you want to know in a static position what direction you're pointing, you need something other than that. So the addition of the dual antenna GPS will give you that, because it's just always calculating the difference between the 2 antennas. Or you can add on an IMU that has a magnetic sensor in it, but the magnetic sensor seems to be confused by lots of things in the environment. So that's a problem.
Yeah, right.
And as you said before, as you're driving along, your vehicle's not going to be jumping around on you and flipping sideways, but still, you can't trust it enough, you know, because if you're taking, say, odometry off the wheels to figure out what direction you're going, or you're just assuming you're going straight, well, as soon as you start assuming things, that'll get you in trouble there
Yeah.
too. So
Yeah. All right. Well, good. No, it's good to talk through it. I'm not opposed to it. It's just I'm trying to save myself a couple $100 for that extra unit.
and if you don't mind paying the shipping later, you could, you know, build it a piece at a time, and then, you know, get the first pieces running, and then if you decide to add on heading, then you can buy the module and add that on later. I think what did I find out? It cost me like $21 shipping the last time I ordered something.
Yeah.
So that's something to keep in mind there, that, you know, if you order it all at once, the shipping's less, but then again, if you got these extra pieces that you're not going to use or whatever, that could run into a problem too.
Yeah, that's a good idea. Just start simple and then grow from there.
But one of the things that might come up is, you know, which radio do you want? Do you want the short range or the medium range or the long range? And, you know, if those guys can give you a better estimate of, you know, can you really trust the numbers or not? That'll give you an idea of what you want to get there.
Yeah.
And other than that, because that's the type of thing, if you buy the short range radio and then you decide it won't work, then you have to buy a whole nother radio to replace that. But then if you buy the long range radio, is that really, are you paying, I don't remember what the prices are. I was thinking the prices are fairly high on those radios, that, you know, there might be a big jump between medium range and long range. And if you don't need it, you may not want to pay that for it. But again, they might have, they sell enough of these and that enough people are using this stuff that they can give you an idea of, you know, how happy people are with this stuff.
Yeah, cool.
Now, you were the one that said you could get the DOT data. Are you in Illinois? Is that where you're from?
Wisconsin.
Wisconsin. Do you know if they have the free data there?
They do. Yeah, I subscribe to it. It's and it's free, but it was in some ways it sounds like an extra component. I'd have to learn how to use that data, subscribe to that data feed. So
Well, it's not real hard to use it. It's just that, again, you've got two options. If you're getting over the cell phone network, you have to have a cell phone receiver right on your vehicle, and then it receives it directly. So wherever you are, as long as you have cell phone reception, that will work. And you just need to have a program in between that receives the data and sends it to the board. So that's not a big deal. Now, one of the things I was doing, I had, before I had my cell modem receiver, I put a laptop in front of my house in my car that was connected to my home network, and that would connect me through the internet to give me the correction data. And then I had it connected to a radio that would then transmit that to my vehicle driving around. So it's like having a base station, but the base station was actually getting the DOT correction data instead of using another receiver and another antenna. So there, you know, somehow you got to get the correction data into a receiver on your vehicle, and that's what that comes down to. So you can either build your own base station, or you can use the DOT data and get it in a couple of different ways. And speaking of radios between your base and your vehicle, the time I actually ran this, I had some of these Swift Nav radios. When we bought the Swift Nav eval kit at work, it came with these two radios that are fairly high-powered 2.4 gigahertz radios, and I just had those connected because they're basically like a serial port replacement. You've got serial connections. You just unplug the serial, plug the two radios in, and it just magically goes over that. And I believe that's the way those XB radios work too. It's just a serial port replacement. And what Al's doing, or what he wants to do, is set up a Wi-Fi network on his property. And if you can get enough range, you could push this data over Wi-Fi. Or if you can't do that, somebody told me that they're using cell modems where they have a base station that talks to a cell modem that puts the data out on a server somewhere, and then the rover has a cell modem that gets that. So they're using their own base station, but they're using the cell modems to get the data back and forth. So again, so not only do you have a lot of options on the GPS module itself, now you get a lot of options on the radio, how to get your correction data back and forth.
Fun, fun, fun. Things are going well though.
And since we're talking about GPS, something I thought I could do, I was going to do this yesterday, but it rained all day, just a light rain, so I didn't want to try anything yesterday. And I got the other problem if I put my robot out in my front yard afterwards about somebody stealing it. So you either have to sit there and watch it or chain it down to something. And I see today it's going to get almost up to freezing outside, so I don't want to sit there and watch it. But what I was thinking about doing was putting my robot out in the front yard. It's got the two receivers and the two antennas, and I'll just disconnect the wire between the two, which gives me moving baseline, and hook up my laptop. I'll hook up my Windows laptop and run 2 copies of the uBlock software, and just simply start recording the static, in a static condition. Watch the, what do they call it, the ground plot. So if I feed correction data to one of the 2 receivers, I should get my nice tight, 1 to 2 centimeter pattern. And the question is, what's the other one going to do if I don't feed any correction data? Because my theory has always been that with the new dual band receivers and 4 constellations of satellites, you're picking up data from like 30 some satellites at once. And I'm just wondering if, with this newest generation of stuff, is that going to be acceptable for some people? Can you get it down to say a 1 foot diameter or 2 foot diameter? And that way, that would tell me. So I figured if I took it out there and set it up, and it says on Windows, you can record the desktop by doing like a Windows Alt R or something. So I won't even have to screw around with that. Hopefully I can just turn that on and record it. So I might get around and try that today, because everyone, once in a while, somebody says, well, how good are these things with no correction data? Well, that's the way to find out, is set it up and try it and see what it looks like over time.
Yeah, even a static test, Jeff, like if you have your RTK and then you have the 2 antennas and you have known distance and you just did a static test, one having RTK fixed, this other one should rotate over time. Yeah, you record it for a day. The one that's not getting corrections will drift. But it'd be interesting to see how far it drifts around.
You're saying somehow those 2 are connected together, or are you just saying
No.
2 independent ones?
Exactly the same thing you were saying, just a static test. So you have 2 GPSs, your 2 ArduSimple boards, and one you're feeding corrections into,
Right.
and then one you're not feeding corrections into.
Right.
If you just do a static test and just have the 2 antennas in a fixed location, what will happen, this one that's getting RTK will stay fixed at 2.5 centimeters. This one will drift. It'll go like this throughout your day.
And that was my whole point, that I want to see that, but I want to see how far it drifts.
Okay.
Without sending the correction data.
I did that about 5 years ago, but I haven't done it lately, so that'll be cool to see. Maybe it's been 8 years now.
I don't know that I've tried that now that I've got either the dual band receivers. I did that, with the single band stuff. And this goes back far enough. I've done this with single band and GPS only, and in those days, that's where they were claiming you could get the 2.5 meters CEP. And we're not quite sure what that means, but I'm just thinking that the third thing I didn't mention was they put up just a whole crap load of satellites in the last few years. So as you say, you fire it up, it says, I'm seeing 31 satellites. So it seems
It's
like
amazing.
at that point with that many satellites and the dual band, which gets rid of some of your errors, hopefully that will, improve it enough that maybe it's good enough for some people.
Yeah.
But we won't know until we try. And then when somebody asks and says, well, how accurate are they? I say, well, go watch this YouTube video and you can decide for yourself. And the other thing that came up just within the last month or so, the Minnesota DOT upgraded and they added the Galileo correction. So before that, you could get GPS and GLONASS correction, and then they shut the whole thing down and said, okay, now we're providing all 3 if you want it. And it turns out you're not forced to use that. I can still use the old mount point, and it still just gives me the GPS and GLONASS. So that'd be another test I can run someday, is set the 2 up and run one on with the extra correction data and see if that gives me even more improvement over my 1 to 2 centimeters that I've got right now.
Wow. You're going to be able to sew embroidery using GPS.
Which actually, if you have your own base station, you're getting as much correction data as your board set up for. So you could actually get 4 constellations if you want to run the Beidou also. So if you have your own base station set up here, and then your rover's over here, and your base station is sending out whatever correction information you tell it to, so it can see all the satellites, so it can actually generate more information than what I'm getting off the DOT service. And that, again, that may give you better correction or better fix. But I don't know. I haven't tried these things. They're just all theories that I have. But like in Al's case, you've got your own base station set up, and you're telling it what correction data to put out. And you'd have to look through your documentation to see if it tells if you can select between types of satellites, or it just says put out correction data. And then when it gets to your other site, since they're both the same brand, and you're controlling what correction data is putting out, you should get a pretty good, fix based on that.
We shall see. I mean, at the moment, it's both the base station and the rover antenna are close to the house, so I'm sure I'm getting deflection. So I need to get them out into the yard and away from the house. Matt, Jeff, anything else? It's the top of the hour.
That's all I can think of.
Matt,
Robot building day.
guys in Argentina, anything?
Nah, holding on, trying to stay healthy down there.
Yeah, like everybody.
Everybody.
Alan, any last thoughts, words, questions?
No, good stuff. It's always good to hear the updates. I appreciate it.
Okay, guys, stay 6 feet apart. I'll talk to you later.
All right. Great
I'll
weekend.
get back.